now I need to find out where does that equal 0. Let's add this portion to both sides. Let's square both sides, and as part of that, for lack of a better word, distribute the squaring to the two factors here and the two factors here. Squaring of this factor will get rid of that denominator in the exponents. Let's multiply both sides by the first power of this and of this. So that, for example, we'll see this part canceled on the left side, but show up to the first power on the right side. Similarly with this portion. Let's expand this as we work to solve for x. First, taking care of the quantity c minus x, all of that squared, showing up in two spots. And on the right side, distributing the x squared. Seeing the x cubed and the x to the fourth is making this look really not so nice, along with the fact that we also have the a, b, and c in there, but x is what's being treated as the variable. On this side, I'm distributing the a squared, and then I'll add to that distributing the x squared. And that really doesn't look very nice, but notice that these last three terms show up exactly the same on both sides. We can cancel those out and subtract b squared x squared to the other side so that everything will equal 0, and the highest power of x that we'll have is 2. So that we're dealing with a quadratic in terms of x. Writing this in descending powers of x. And furthermore, I will factor the x squared out. So solving that for x will hopefully we'll be able to find out the critical value or values. And I'm going to apply the quadratic formula. Doesn't that look like something that would be fun to simplify? But we have to do it. Here I've taken care of the two negatives canceling each other out. I've squared here. Here I've just brought the a squared c squared to the front so far. We have as a common factor 4a squared c squared. So I'm going to factor that out. And I need some more room again to continue simplifying. All right. Distributing that subtraction. And then combining like terms here. That's starting to look nicer. Let's see here. Taking the square root of each of these factors. To a, I'm going to put the square root of the b squared first. So the square root of 4a squared c squared b squared would be 2acb, but I've written that as 2abc. And I'm going to factor out 2ac in the numerator, leaving us with a plus or minus b. All over 2 times a minus b. Got a little error there. I'm going to factor in the denominator. By the difference of squares. Now, I haven't mentioned it yet, but the a squared minus b squared cannot equal 0. Of course, the 2 is not 0, so we're not worried about dividing by 0 there. But a plus b was equal to 0. then A would equal negative B. But B was, should have said here, strictly positive. Sorry about that. Then that would make A strictly negative, which would contradict that A was strictly positive. Okay, so that can't happen. A minus B cannot equal 0. So we cannot have A equal to B and get this solution. Talk about that more in a bit. Then in the first case where we have the subtraction, we can cancel the 2's and the A minus B's. In the second case where we have addition, again, cancel out the 2's, this time cancel out the A plus B's. The second one is a problem, because if we rewrite that fraction, since B is positive, A minus B will be smaller than A. Dividing something by something smaller than itself will give us something greater than 1. That would give us that X would be strictly greater than C, putting it outside of that interval. That is not possible. So we reject this. It's not a critical value within our closed interval. We're dealing with that as the only critical value within our closed interval.